State and prove the Morera's theorem. Statement: if f of z is a continuous in a simply connected domain omega, and if for every closed contour C the domain omega f of z integral of f of z dz is equal to 0 for f of z is analytical within omega. Now proof: let a be a fixed point and let z be any variable point inside the domain omega. Now since by the hypothesis the value of the integral a to z f of z dz is independent of the path if it is a one valued function of z, let us denote it by f of z is equal to integral a to z f of w dw, which implies f z plus h is equal to integral a to z plus h f of w dw. Therefore f of z plus h minus f of z is equal to integral a to z plus h f of w dw minus integral a to z f of w dw, which is equal to square bracket starts integral a to z f of w dw plus integral z to z plus h f of w dw minus integral a to z f of w dw square bracket close, which is equal to integral z to z plus h f of w dw. This is equation 2. The integral in the 2 is independent of the path and may be taken along a straight line segment joining the z to z plus h. We have f of z plus h minus f of z upon h minus f of w f of z is equal to 1 upon h square bracket starts z to limit z to z plus h f of w dw minus h of f of z square bracket close, which is equal to 1 upon h square bracket starts z to z plus h f of w dw minus integral z to z plus h f of z dw square bracket close, because integral z to z plus h f of z dw is equal to f of z integral z to z plus h dw, which is equal to f of w f of z w limit z to z plus h. So f of z z plus h minus z is equal to h of f of z square bracket close, so equals to 1 upon h integral z to z plus h square bracket starts f of w minus f of z square bracket close dw. As the fw is a continuous at z, therefore for a given epsilon greater than 0 there exists a delta greater than 0 such that f of w minus f of z is less than epsilon for all the w satisfied by modulus of w minus z is less than delta. Now let us choose that h such that modulus of h is less than delta implies, so that the relation of modulus of f of w minus f of z is less than epsilon satisfied for the every point W in the line segment joining Z to Z plus H. Thus, modulus of f of Z plus H minus f of Z upon H minus f of Z modulus close is equal to modulus starts 1 upon H integral Z to Z plus H square bracket starts f of W minus f of Z square bracket close dw modulus close is less than equal to 1 upon modulus of H integral Z to Z plus H modulus of fw minus fz modulus of dw, which is less than equal to 1 upon modulus of H epsilon integral Z to Z plus H dw, which is less than equal to 1 upon H epsilon modulus of W limit Z to Z plus H, which is less than equal to 1 upon modulus of H epsilon modulus of Z plus H minus Z, which is less than equal to 1 upon H epsilon H is equal to epsilon, so which implies the modulus of f of Z plus H minus f of Z upon H minus f of Z modulus close is less than epsilon. Taking the limit H is 0, we get limit H tends to 0 modulus of f of Z plus H minus f of Z upon H minus f of Z modulus close is equal to 0. So limit H f of Z plus H minus f of Z upon H is equal to f of Z, so f of dash Z is equal to small of f of Z, hence the f of Z is a analytical in omega.